Okay, this is lesson 7.1 and 7.2, simple and compound interest. Now, depending on how the units proceed, this could be titled 8.1 and 8.2. But at the time of recording, I anticipate this being our 7th unit. So 7.1 and 7.2. So in this video, we're going to compare what simple and compound interest are. And there's a lot of terminology in financial math. So what I've done is I've gone ahead and made a big table to try to demystify all the terminology. Now, putting this at the beginning of the very first lesson could make it intimidating. I'm not trying to make it intimidating. What I'm trying to do is give you a place that you can reference. If you ever see a letter and you're not sure what it represents, at any point in this unit, here is what it represents. So a bunch of variables representing a bunch of terms with their definitions. We're going to use these as we go through, and that's how you're going to learn it. But in terms of reference, here it is. Here is all of the letters, all the variables, all of their meanings, all of their definitions in one spot. Okay, so what is interest? Well, when you give the bank your money, what they do is they give you a little bit extra to hold your money, and that's because the bank uses your money and reinvests it in an attempt to make a profit. And banks are generally quite successful at making money, so they're able to give you a competitive interest rate. And interest rate is just extra money for holding onto your money. So if that's, say, 1%, if you give the bank your money, you'll get 1% every year of that money back as interest. It works the opposite when you borrow money. When you borrow money, they'll give you all the money up front. So say you borrow $100 and they charge you 1% interest. That means you have to pay back the 100 plus the extra interest. So interest goes both ways. It just depends who has the money. If the bank has the money, the person giving the bank the money gets the interest. If you have the money, it means you're giving the bank the interest. And it's because the time value of money. And what that means is money is not always worth the same amount as you move forward in time. Due to inflation or due to how the economy is going, the value of money changes. So it's an interesting topic we're going to continue to explore here in financial math. So there's two types of interest that you can encounter. One's called simple, one's called compound. So how I'm going to demonstrate what these are is I want to show you a $1,000 investment over 5 years in two different investment options. One will be with simple interest and one will be with compound interest, so you can see the difference between the two. So we're going to go all the way down to the bottom. And we're going to look at Carson. Carson decides to invest $1,000 for 5 years and has two choices to invest his money. Option A is called a dividend, and it earns 5% on your principal amount. This is the simple interest example. I'm just going to write it up here. Simple interest. And option B is a savings account that earns the same interest rate, 5%, on the principal and any interest earned. This is the compound interest example. Now, the word simple and the word compound will have more meaning when you see how the interest is calculated. So let's start with the simple interest example. Carson's going to deposit $1,000, and in the first year, he's going to earn some interest. How much interest? Well, at the beginning of the first year of his investment, he'll have $1,000 in his bank account. He'll earn 5% of that $1,000. So how we calculate that is we change 5% to a decimal, 0.05, and we multiply it by 1,000. What we get is $50. In a simple interest example, you only earn interest on the principal, which means you only earn interest on the $1,000 amount. But you earn that interest every year, so every year he's going to get an extra $50. Now he has to have that money stay there for the 5 years, but if he does keep it there, he earns the $50. So what ends up happening is basically he earns $50 every year. At the end of the first year, he'll have $50 more. At the end of the second year, he'll have another $50, so $1,100. In the third year, he'll start with $1,100, earn his $50, and he'll have $1,150. At the start of the fourth year, he'll start with $1,150, and he'll end with $1,200. And after the last year, he'll have $1,250. To get the closing balance, we just add the interest. So what's happening here? Well, we're growing by $50. That's a constant growth. And constant growth just means it's linear. If we were to graph this, his money is going up linearly. So it's a controlled growth. Option B, compound interest, doesn't quite work the same. The way compound interest works is you earn interest on the opening balance. So in the first year, it'll look the same. There's $1,000 in the account. He earns 5%. 5% is $50. Interest earned is calculated now by 0.05 times open balance, by how much is in the account at the beginning. So I'm going to get a calculator because now we're going to have to do some calculations because it's not just going to be $50 every year. Because at the beginning of the second year, he has 1,050. So 1,050 times 5% is 5,250. Now, why is the number different? Well, the number is different because $50 is the interest on 1,000, and the extra $250 is interest on the $50. So it's interest on last year's interest. Boy, is that interesting. My first of many interest jokes. To get the closing balance, we add across, and we end up with 1102.50. If we compare to the simple interest, we've got an extra $2.50. That may not seem like much, but watch what happens. Next year, we start with 1102.50. And when we go to calculate interest, we calculate it on 1102.50. And we have earned in this year $55.13. All right, where'd the $55 come from? Well, $50 came from the interest on the original 1,000. $250 came from the interest on the first year's interest, the 50. But there's still an extra $263. Where'd that come from? Well, that came from the interest on $52.50. We earned interest in the third year on the 1,000, on the interest from the first year, and on the interest from the second year. Do you see what's happening? We're earning interest on interest, and then interest on interest on interest. That's where the word compound comes from. Compound means you're earning interest on your interest, on your interest. And it goes on forever as long as your investment is still in the bank. If we add across the column here, we get, I'm not going to stop showing some of this math on the calculator because it would take a long time. We get 1157.63, which is now $7.63 more than the simple interest. And the longer we do this, the more we're compounding, the more the difference is going to become, because we're going to keep earning interest on all the extra interest amounts. All right, so now we start with 1157.63. So there's an extra 763 in the account now. The next interest is 57.88. And 12, 15, 51. Now we've got $15.51 more. As you can see, this amount's creeping up. The difference was $2. Now it's $7. Now it's $15. That amount is growing, and it's growing at a growing rate. It's not just going up by the same amount every time. Compound interest is a wonderful thing. 12, 15, 51, if we calculate the interest on that, 5% of that is $60.78. Now we're at a point where we're already earning a whole $10 more every single year. It doesn't sound like a lot, but eventually that number gets quite large. Now we are at the end of our thing, so we won't get to see how big, but we could continue and you could see. After 5 years, the difference in the investment is $26.29. It's an extra $26.29 just because of compound interest. So this is not called constant growth. This is called a constant growth ratio. And that may ring a bell. When you're growing by a constant rate, it's exponential growth. So when we go to look at the equations to calculate all this, what you're going to expect is this. You're going to expect a linear equation for simple interest, and you're going to expect an exponential equation for compound interest, and that's exactly what you get. When we calculate interest, we don't want to have to make a table like this to get to the end. We want to be able to ask the simple question, if I start with $1,000, how much will I have in 5 years? If I start with $1,000, how much will I have in 5 years? We want to be able to go from the beginning to the end without a large table. That's the beauty of the equations. So on the next page, you're going to see the equations. And this is where we start to introduce some letters, some variables, and again, we can always reference back to the terminology to see what those represent, but I'm going to talk you through two of them, or some of them now. Simple interest has two equations. You'll be always provided with these equations. You do not need to memorize them. The first one is I equals PRT, and the second one is A equals P plus I. The capital letters and the small letters are important. Little r and little t are interest rate and time. These capital letters refer to dollar amounts. So anytime you see a capital letter in financial math, you're talking about money. So interest in dollars, principal in dollars. Principal means how much you invest at the beginning. The second equation means A stands for amount or final amount. Final amount is calculated by adding how much you started with and how much interest you earned, and that kind of makes sense. So let's see if we can break this down. Simple interest. Interest is earned on the principal only, and you get that same amount of money every year. Interest is paid out as it is earned and does not become part of the interest earning amount. So basically you get $50 every year given to you. And it doesn't factor into the calculation of interest in future years. And it is normally used for a single period of less than a year. It's usually for short-term investment. But I illustrated the example otherwise on the other page. And here are the two equations. So we'll do an example with those two equations, and actually we're going to do that right away. We're going to come back to the compound and this effective interest rate business. We're going to go do the simple interest example right now. So it is number one. Nusian invests $3,240 at 2.4% simple interest. Calculate the interest he earned each year. So how do we do that? Well, we use the equation for interest. Interest equals PRT. So we're going to go through and figure out which, we need P, R, and T. We're going to go figure out what those are. P stands for principal. That's how much he invests. So the P in this question is $3,240. R is the interest rate as a decimal. This is our R. To make it a decimal, we divide by 100 and we get 0.024. That's our R. And T, calculate the interest earned each year. That means 1 year. Time is always in years, and if you're given something other than years, you need to convert it to a year. Like if you get something that says 6 months, that's half a year, so you use 0.5. So to do A, we get I equals PRT. P is 3,240. The interest rate is 0.024, and the time is 1. If we multiply those three things together, we get how much interest a Nusian would earn every year. 3,240 times 0.024 equals, I didn't do times 1 because it's 1, and we get $77.76. So that's how much he earns each year. B says calculate the amount and the total interest he earns after 20 years. Well, amount is A. The A equation is A equals P plus I. P is the principal, we know that. I is the interest earned in 20 years. We do not know that. If he earns that much every year, though, it's just that number times 20. So we can find it. How do we find it? We can use the I equation. I equals PRT. We want to know first how much interest he earns how much interest he earns in the 20 years. So what we've done is we're going to do the same question we just did, but with a T of 20. So the same numbers, 3,240, 0.024, times 20, which is just that number times 20. And we get $1,555.20. Now, to calculate the amount, this is the total interest, I. We just found that. To find the amount, we need to add the total interest to how much we invested, because that's how much money you would have now. You still have the amount you invest, and you get the interest. P plus I, 3240 plus 15520. If we add that up, we get our final amount, and do this in my head, 4795.20. There's your final amount. So simple interest is both simple and interesting. Second joke. Simple because the calculation is fairly straightforward. It's just multiplying three numbers to find out how much interest. Once you find out how much interest, you can always add it back to your principal to find your final bank account amount. The interesting part is because it's money. All right, let's try a compound interest example. It'll be question 2. I'm going to go back up and introduce the formula, and then we'll do question 2. There's 2 more for you to try about Emily and Evan, question 3 and 4. You can try those after the lesson, and the answers are included in brackets, so try to get those. If you can't come up with those successfully, ask me tomorrow and I can show you how to work through them. All right, compound interest. Compound interest is calculated on the accumulated value of the investment, which includes the principal and any interest from prior periods. The interest rate is stated per year, but compounding periods can be more than once per year. So what this means is that instead of dealing with R and T, like we were in simple interest, we're going to deal with different letters I and N. So what is I? Well, I is just the interest rate divided by how many times you compound per year. It's called the effective interest rate, and I'm going to show you how to calculate it over here. N is the time in years times how many times you compound per year. Compound just means how many times you calculate interest. So when you see compound interest rates written, they'll say 2 things. They'll say 5% per year, and then you'll see the word compounded, and it will use a word like annually, semi-annually, quarterly, monthly, biweekly, weekly, or daily. And that's how many times you calculate interest. That's your compound per year. That's the CY. So before we can use the compound interest equation, we need to be able to find I and N. So when we do question 2 here in a second, our first step is going to be to figure out what I and N are. So we'll get an example of how to do that. And for every question we're going to do from this point forward that doesn't involve simple interest, so the next lesson is about present value, it's a compound interest example, we're going to use I and N. When we do annuities, we're going to use I and N. So finding I and N is going to be something you're going to do over and over and over again, and then hopefully it will start to make more sense. But for now, we need to find I and N before we can use the equation. What is the equation? Some familiar letters here. A still means final amount. P still means principal. 1 is the number 1, plus I, the effective interest rate, to the exponent N. N is the exponent because it's exponential. This time, the compound interest equation is set up to calculate A, the final amount. So if you want to learn how much interest you earned, you just subtract how much you invested, and that will give you the interest. Just a rearranged version of this equation. Since simple interest solves for I, you may want to know A. Compound interest solves for A, you may want to know I. So let's try an example. But first, effective interest rate. So when you see words like this, where it says 5% compounded and then one of these words appears, you need to know how many times per year that is. Annually just means 1 time per year, which makes the question a little bit easier to do if it says annually. Semi-annually means twice per year. Quarterly means 4 times per year. Monthly means 12 times per year because there's 12 months in a year. I'm going to skip biweekly for a second. Weekly means 52 times per year. There's 52 weeks in a year. And daily means 365 because there's 365 days in a year. That's what the bank uses as well. 365.25 technically because of leap years, but we'll stick with 365. Biweekly is the one that most people confuse. People think there's 2 weeks in every month. Kind of true. But biweekly does not mean 24 because there's actually more than, people think there's 4 weeks in every month. If there was 4 weeks in every month, that would mean there'd only be 28 days in a month. But we know there's sometimes 30, sometimes 31. There is 1 month with 28 days sometimes. But we can't say there's 4 weeks in a month. Now you receive a paycheck generally bi-weekly, and you will receive 26 paychecks a year. And the reason you receive 26 paychecks a year is because you receive one every other week. And if there's 52 weeks in a year, you would receive 26 paychecks, which is not 2 times a month. It's actually half of the number of weeks. So when you see biweekly, use the number 26, not 24. If you wanted something that was 24, you would call it semi-monthly. That would be 24. Semi means twice per, and month is 12, so that would be your 24, semi-monthly. And that means you would get, like, if you got your paycheck semi-monthly, you'd get them on the 15th and 30th of every month, or the middle day of the month and the last day of the month, something like that. And that's possible too, but then you'd be only getting 24 paychecks instead of 26. Okay. So why is this important? Well, this number is what we use to find the effective interest rate and the number of compound periods per year. So let's do an example. Charlotte's grandparents invest $5,000 at 4.8% compounded quarterly when she was born. How much money will it be worth on her 21st birthday? So here's the equation we're going to use for compound interest. We know it's compound because it says compound. A equals P, 1 plus I to the exponent n. To use this, we need to know P, I, and n. So over here, I'm going to write P, I, and n. P stands for principal. $5,000 is the principal. $5,000 is invested. A is what we're trying to find. We want to know how much on her 21st birthday. Now, in order to use I and N, we can't just use 4.8% and 21 years because this is not R and that is not T. R and T would be 0.048, 4.8%, and T would be 28 years, or 21 years. We're dealing with I and N. I is effective interest rate. So we need to adjust those numbers based on how often we compound. In this question, we compound quarterly. So the magic number in this question is 4. Watch what happens with the number 4. It's going to appear in 2 spots. We take our interest rate as a decimal, 0.048, and we divide it by 4. That gives us I. That gives us the effective interest rate. Because you don't get 4.8% every quarter. You get a quarter of that interest rate every quarter. So by the end of the year, you get 4.8%. So really, you're only getting 1.2% every quarter, but you get 4 of them in every year. So you do get your 4.8% just spread out. N. N is how many times we need to calculate interest. Well, 21 years is how long the investment's staying in the bank. And we're calculating interest 4 times per year. Times 4. There's the other way the number 4 is used. We divide the interest rate by 4, and we multiply the years by 4. And this will happen for every compound interest question. You will always divide the interest rate by whatever word comes after compounded. So if it was monthly, 12, you would divide by 12, and you would multiply by 12. And that'll happen for every compound interest question. So we have to get used to doing I and N before we can use the equation. Now we can use the equation. Fill in what we know, 5,000, 1 plus 0.012 to the exponent 84. Type that in a calculator. We'll do this one on my calculator. We got 5,000, oops, We got 5,000. 1 plus 0.012. People always miss the extra 0. Make sure you get it. Exponent button, 84. And it will do it all for you. We get $13,618.62. That's pretty wicked. $5,000 investment has become $13,600. Pretty sweet. Okay, that's it for our first lesson of the financial unit. Thanks for watching. Try 3 and 4 and see if you can come up with these answers, and we can clarify tomorrow if you are not able to get those answers. Have a great day, and I will see you next time.